All right, welcome back. You know those excerpts you sent over about extraction methods? Those look really interesting,
Yeah.
especially all the stuff on leaching and liquid extraction.
Mm.
It seems like a field that's more impactful than people realize.
It really is
I
everywhere.
mean, before digging into these sources, I don't think I ever really considered how much we rely on extraction in so many different industries.
Right. Our goal today is to kind of break down how these techniques work, why they matter so much, dive into the equipment, uncover some surprising applications, and maybe even some historical tidbits along the way.
Sounds good to me.
Yeah.
Let's start with solid liquid extraction.
All right.
So that's more commonly known as leaching. I
Right.
think most listeners probably already have a pretty good idea of what it is, but just to be sure, think about brewing coffee.
Yeah.
That's leaching in action.
Absolutely. It's all about using a solvent to pull out soluble components from a solid material. What's fascinating is the sheer variety of methods and equipment used depending on the scale and what's being extracted. For example, you have stationary bed leaching,
Okay.
which is a batch process.
Sort of like steeping a giant tea bag.
Exactly. Then you've got moving bed leaching, which is continuous,
Uh-huh.
like a conveyor belt of soybeans being showered with solvent.
So it's like choosing between a French press and a drip coffee maker.
Ah, I like that.
Different approaches for different needs.
Now, digging a bit deeper into stationary bud leaching, you have equipment like the batch percolator.
Okay.
This is often used to make concentrated extracts,
Mm-hmm.
particularly for things like alkaloids,
Right.
which are used in pharmaceuticals. It's basically a tank with a perforated bottom where the solvent flows through the solid material. But here's where it gets interesting. Even packing of that solid material is absolutely crucial.
Otherwise, you get that channeling, where the solvent's kind of taking the easy way out and not actually coming into contact with all of the solid material.
Precisely. And that means you're not getting the most efficient extraction. It's like trying to water your plants with a hose that has holes in it. You'll end up with some dry spots. So to avoid that, the source mentions using horizontal perforated plates,
Oh, interesting.
strategically placed within the extractor to kind of force that solvent to distribute more evenly.
Makes sense.
Yeah.
It's all about making sure you've got a controlled flow.
I
Speaking of which, the next piece of equipment you've got in your notes is the sock slit extractor,
Right.
which, I don't know, it always reminds me of some kind of mad scientist contraption.
It does have that classic lab look, doesn't it?
Yeah.
But it's actually incredibly ingenious. It uses a siphon mechanism to repeatedly cycle the solvent through the solid material,
Oh, wow.
leading to a highly concentrated extract.
So it's like brewing the same coffee grounds over and over again to get the strongest possible cup.
Exactly. That's why it's so popular for extracting compounds that are present in low concentrations or that require multiple extraction cycles for complete removal.
Makes sense. Now, moving on to continuous solid liquid extraction, you've got things like the Bowman extractor,
Right.
which, as I understand it from the source, is this massive system with a bucket elevator
Mm-hmm.
that continuously moves these baskets of soybeans through the solvent. What I found interesting is that it uses what's called half micella,
Okay.
which is basically a solvent that's already got some extracted oil in it,
Right.
which, I don't know, it seems kind of counterintuitive to use a dirty solvent.
It might seem counterintuitive, but it's a brilliant way to maximize the extraction efficiency. The half micella extracts more oil from the soybeans as they move down one side of the extractor,
Interesting.
and then as they go up the other side, they're washed with pure solvent for a final rinse.
Oh, okay.
So you're really getting as much out as possible.
And this whole process happens on a huge scale, right?
Yeah.
I think the source mentioned that these extractors can handle tons of soybeans per day.
That's right.
It really highlights the power of these continuous extraction methods.
Absolutely. Now, shifting gears a bit, your notes also mention leaching by immersion,
Okay.
which on the surface sounds incredibly simple.
Yeah.
You basically just dunk the solid material in a tank of solvent and stir.
That was pretty straightforward.
It does. However, the source mentions that there can be some real challenges with separating those solid and liquid phases after you're done with the extraction,
Yeah.
especially when you're dealing with things like fine particles
Right.
or compressible solids.
Yeah, I could see how that would be a problem.
You're right. Separating those phases can become a real bottleneck. The source talks about using things like continuous filtration
Hmm.
or cake filtration to try and tackle this issue, but it's definitely something that engineers have to consider carefully when they're designing these systems.
All right, so we've covered a lot of ground on solid liquid
What
extraction,
have?
from simple batch processes all the way to continuous industrial scale systems.
Right.
It's amazing to see how many different approaches there are.
And that's just one side of the extraction coin.
Oh, right.
We still need to dive into liquid extraction.
Yeah, I'm ready for it. Before we do, though, I'm just curious, why don't we just use distillation for everything?
Uh-huh.
I mean, it seems like the more straightforward way to separate liquids, right?
Well, distillation is definitely a go-to method,
Uh-huh.
but there are times when it's just not practical or
Yeah.
even possible.
Um,
You know, if you're dealing with compounds that are really sensitive to heat,
Right.
distillation could damage them. Or sometimes the boiling points of the components that you're trying to separate are just too close together.
Right.
It makes distillation inefficient.
So it's kind of like trying to separate two types of pasta
Yeah.
that are almost the same size
Right.
using a colander. It's not impossible, but it's going to be incredibly tedious.
Exactly. That's where liquid extraction comes in.
Okay.
It relies on the principle that different compounds have different solubilities in different solvents.
Uh-huh.
So you can use a solvent to selectively extract a target compound from a liquid mixture.
And I'm guessing the choice of solvent is pretty key here.
Absolutely. It's like choosing the right fishing lure.
Yeah.
You need something that's going to attract the specific compound you're after
Right.
while leaving the others behind.
Makes sense.
Now, the source mentions two main approaches to liquid extraction.
Okay.
You've got batch and continuous flow.
So batch is kind of like a one-time deal, and continuous flow is more ongoing.
That's a good way to think about it.
Okay.
Batch extraction is simple.
Yeah.
It's often used for small-scale applications.
Mm-hmm.
You mix the feed liquid with the solvent,
Right.
let the phases separate,
Uh-huh.
and then draw off the layer that contains your desired compound.
Kind of like making a single serving of French press coffee.
Exactly.
Steep the grounds, let them settle, press the plunger,
Yep.
separate the coffee from the grounds.
Continuous flow extraction, on the other hand, is
Uh-huh.
more like your automatic drip coffee maker. It's designed for larger-scale ongoing operations.
Okay.
And just like with solid liquid extraction, you've got a whole range of equipment designed for continuous flow liquid extraction.
Now, I noticed the source goes into a lot of detail about different column designs,
It does.
like baffle plate columns,
Mhm.
perforated plate columns,
Right.
spray columns, and packed columns.
Yep.
And it seems like each one has its own advantages and disadvantages.
It's a lot to take in, I know.
Yeah.
But essentially, the goal is to create those optimal conditions for those two liquid phases to come into contact and exchange compounds.
Right.
For example, baffle plate columns are pretty simple
Yeah.
and robust.
Okay.
They can handle solutions that have suspended solids in them, but they might not be the most efficient when it comes to mixing.
Because the flow is kind of disrupted.
Exactly.
It's not as smooth.
Now, perforated plate columns, on the other hand,
Yeah.
have lots of small holes
Okay.
that allow for better mixing,
Uh-huh.
but they can be more prone to clogging.
Right. It's like choosing between a coarse filter and a fine filter.
Mm-hmm.
You know, the fine filter might give you a clearer result,
Right.
but it's more likely to get clogged.
And then you've got spray columns, which seem like the simplest option,
Yeah.
but the source mentions that they're not very efficient because of recirculation.
Right.
Meaning some of that continuous phase ends up going back through the column multiple times.
It's like trying to rinse dishes with a spray nozzle that's too powerful.
Yeah,
You know, the water just bounces off the plates.
exactly.
Instead of cleaning them.
And finally, packed columns,
Yeah.
which are filled with materials like Rishig rings
Oh.
to increase the surface area for contact between the phases. But the source does point out that they can be limited by the amount of liquid they can handle.
Right. It's like trying to pour a gallon of water through a coffee filter.
Yeah.
It's going to take a long time.
Exactly. So choosing the right column design really depends on the specific needs of that extraction process.
It's like being an engineer is all about making those kinds of trade-offs.
It is.
Finding the best balance
Mm-hmm.
between efficiency, cost, and the characteristics of the material after
Absolutely.
it's being extracted.
Now, speaking of innovation,
Yeah.
the source highlights one particular column design that seems particularly clever,
Okay.
the Scheibel column.
And what makes it stand out from the others?
Well, the Scheibel column was a real game changer because it addressed a common problem
Oh,
in
yeah.
traditional columns.
Okay.
Poor liquid redistribution.
Right.
It incorporates these rotating agitators
Oh, wow.
and wire mesh sections
Interesting.
that help break up the droplets and create more contact between the phases.
So it's like giving the whole system a good shake. Just make sure everything's mixing properly.
Yeah, exactly.
That's pretty amazing.
Yeah.
And it makes me wonder, why are we going to all this trouble to extract things in the first place? Like, what's the driving force?
That's a great question.
Yeah.
And it gets at the heart of why extraction is so important.
Okay.
Think about it.
Yeah.
Extraction allows us to isolate and purify valuable compounds from these complex mixtures.
Okay.
We use it to extract essential oils from plants for perfumes and aromatherapy,
Right.
caffeine from coffee beans, and even precious metals from ore.
It's like taking that raw material and refining it
It is.
to get the essence of what we need.
Yeah.
I never really thought about it that way before.
It's a fundamental process that touches so many aspects of our lives.
Yeah.
And the applications are incredibly diverse.
Like what?
Well, we use extraction in food processing, pharmaceuticals,
Right.
cosmetics,
Oh, okay.
environmental remediation,
Wow.
and even forensic science.
It's really mind-blowing when you start to think about how widespread its impact is. And I imagine as our understanding of chemistry and engineering advances,
Yeah,
so do our methods for extraction.
absolutely. For example, the source talks about how important it is to consider factors like temperature,
Right.
pressure,
Yeah.
and even the choice of solvent to optimize that extraction process.
So it's like fine-tuning a recipe,
Yeah, I like that.
finding that perfect combination of ingredients and cooking time to get the result that you want.
Exactly. And just like with cooking,
Yeah.
there's always room for improvement.
Yeah.
One area that's getting a lot of attention these days is the environmental impact of extraction.
Yeah, that was something that really struck me when I was reading through the material. Some of these processes use a huge volume of solvent.
They do.
And I was thinking, that can't be good for the environment.
You're right to be concerned about that.
Yeah.
The responsible use and disposal in solvents is a major challenge in extraction.
Researchers are constantly working to find ways to minimize solvent usage,
Okay.
recycle solvents more effectively,
Right.
or even replace traditional solvents with greener alternatives.
Like using water or supercritical fluids as solvents.
Exactly. So while extraction is this powerful tool,
Yeah.
we need to be mindful of its environmental impact and strive to make it as sustainable as possible.
Makes sense. And it makes me realize that even with all this technology and innovation that we've been talking about,
Yeah.
extraction is rarely a perfect process.
That's an interesting observation.
What do you mean by that? Well, it seems like there's always some degree of loss. Some residue left behind.
Okay.
It's like trying to squeeze every last drop of juice from an orange.
Yep.
You can get most of it,
Right.
but there's always going to be a little bit that remains.
That's a great analogy. You've hit on a really important point.
Okay.
Extraction efficiency is never 100%.
Right.
There's always going to be some material left behind.
Yeah. And that raises a fascinating question.
What's that?
What happens to those byproducts?
That's a great question.
Are they just considered waste?
Right.
Or could they have some potential value?
Yeah, I mean, is there any way to kind of reuse them?
It really depends
Okay.
on the specific process and the materials involved.
Right.
In some cases, the byproducts might be considered hazardous waste and need to be disposed of properly.
Yeah.
But in other cases, they might contain valuable compounds that could be extracted
or
used in other processes.
So it's all about finding ways to kind of close the loop,
Exactly.
create a more circular approach to extraction,
That's right.
where waste is minimized and resources are used more efficiently.
And that's a trend we're seeing more and more of these days as sustainability becomes a top priority across all these different industries.
So we've gone from the basic principles of extraction
Yeah.
to the intricacies of equipment design,
Yeah.
now to the broader implications for sustainability and resource management.
It's pretty amazing
It is.
how this seemingly simple concept of separating compounds
Right.
has led us down such a diverse and thought-provoking path.
It really has been quite a journey.
It has. And it's not over yet.
Oh, what do you mean?
As our needs and technologies continue to evolve,
Yeah.
so too will our approaches to extraction.
Okay, I'm all ears. What kinds of changes do you see on the horizon?
I think with the rise of personalized medicine and the growing demand for natural products,
Right.
there's this real push for even more selective and efficient extraction methods,
Okay.
methods that can target very specific compounds
Yeah.
while minimizing waste.
So it's like going from a toolbox with,
Yeah.
general purpose hammers and screwdrivers
Right.
to one that's filled with these really specialized instruments.
Yeah.
Each one designed for a particular task.
I think that's a great analogy.
And I imagine that automation and artificial intelligence are going to play a big role in that as well.
Absolutely. We're already seeing the development of what are being called smart extraction systems that can actually monitor and adjust parameters like temperature, pressure, and solvent flow in real time.
That's wild.
This level of precision allows for incredibly efficient extractions, reducing both waste and energy consumption.
It sounds like the future of extraction is all about finding that perfect balance between precision and sustainability.
I think so.
But here's something I'm curious about. We've talked a lot about human-designed extraction systems, but what about nature?
Right.
I mean, nature has been extracting compounds for millions of years.
You've hit on a really exciting area of research, biomimicry.
And what is that?
Scientists are increasingly looking to nature for inspiration,
Okay.
studying how plants and organisms extract and utilize compounds in their own biological processes.
So it's like nature's already done the R&D,
Yeah,
and we're just trying to catch up.
exactly. One example is the use of enzymes for selective extraction.
And how does that work?
Well, enzymes are nature's catalysts. They can speed up chemical reactions without being consumed themselves.
So instead of using these harsh solvents,
Right.
we could use enzymes to gently and selectively extract the compounds that we need.
Precisely. It's a much more sustainable approach.
That's pretty amazing.
And then there's bioleaching,
Okay.
which uses microorganisms like bacteria and fungi
Interesting.
to extract valuable metals from ores.
So instead of traditional mining techniques,
Yeah.
that can be so destructive to the environment.
It can be very destructive.
We could use microbes to do the heavy lifting.
Exactly. Again, it's much more environmentally friendly.
Wow. It sounds like the future of extraction is going to be all about working with nature, not against it.
I think that's a great way to put it.
As we learn more about the power and efficiency of natural processes,
Right.
we can apply those lessons to develop even more sustainable and innovative extraction technologies.
Absolutely.
It's really inspiring to think about all the possibilities.
It is.
So as we wrap up our deep dive into the world of extraction,
Yeah.
what's one key takeaway you want to leave our listeners with?
Well, I think the main takeaway is this. Extraction is this fundamental process. It underpins countless aspects of our modern world,
Okay.
from the food we eat to the medicines we take
Right.
to the materials we use to build our homes.
Yeah.
Extraction is everywhere.
It really is.
And as we face new challenges like the need for more sustainable and efficient technologies,
Right.
our understanding of extraction will continue to evolve and shape the world around us.
That's a great point. It's not just about the science.
Right.
It's about how that science impacts our lives and our planet.
Absolutely. And who knows, maybe our listener will be inspired to contribute to this fascinating field.
That would be incredible. Thanks for joining us on this deep dive into the world of extraction. It's been an amazing journey, and we hope you've come away with a newfound appreciation for the ingenuity and importance of this often overlooked field